Okay, that's it. 10:30. We'll start recording. Hello, everyone. This is Destry Atkinson from Long Salt Lake City for the Utah Coffee Break. This morning, we're going to talk about Ruskin airflow monitoring. They have a rather comprehensive line, and I'm going to let our regional manager, Ghassan El Khatib, give you a presentation. After which, when he's done, please let us know if you have any questions. You can either open up your microphone and ask them verbally when he's done, or feel free to send them to me in advance in the chat. So let's go ahead and, Ghassan, I'll let you introduce yourself and get started. Thanks.
Great. Good morning. Thank you. Thanks, Destry. Thank you for the opportunity. Thank you, everyone, for joining us this morning. My name is Ghassan El Khatib. I'm the Western Regional Sales Manager. I support Long in Utah. I started with Ruskin about a year ago. I'm new to Ruskin, but prior to that, I worked in sales for other manufacturing companies. And then prior to that, I did consulting engineering. So I understand the world of consulting and how busy you are. So really appreciate it. Again, thank you for your time. With that, we'll go ahead and start through the airflow monitoring. So why do we need it? It's a code requirement to maintain the ventilation. Now more than ever, we also need to make sure that we're getting the right amount of outdoor air into the building to make sure it's healthy environment. So Utah and many other states have adopted the International Council Code. And so we look at the International Mechanical Code, we look at the International Energy Conservation Code. Currently we're at 2018. 2021 is going to be adopted very soon. It has very similar language as far as the airflow monitoring. All of this is based typically on the standard of ASHRAE 62.1, and we're all familiar with that standard that'll basically determine the amount of outdoor air required based on occupancy, classification, and number of occupants. So we're looking at standard 62.1. We'll also briefly visit standard 111. So as far as the code requirement, yes, we do need ventilation. You got to make sure it's you're maintaining the minimum supply air. Now the tricky part, if you look at variable air volume, if you start looking at variable fan speeds, the requirement is that you maintain the minimum outside air over the entire range of that supply airflow. So we want to make sure it doesn't drop. So just having an outdoor air damper and having a minimum position doesn't really cut it when you look at what other factors you have in the building. Maybe it's the wind, maybe it's the return, the pressurization. So you got to make sure you're monitoring it. You got to make sure you're validating. You got to make sure you commission it, and then you're basically show that you're maintaining the minimum outside air. So that's kind of the language in the code. These are the different sections for International Mechanical Code. We also look at opportunity to save energy. And that's where the International Energy Conservation Code comes in. We have the opportunity to use demand ventilation, and that's reducing the actual amount of outdoor air. And again, you could do that, but making sure you're still maintaining the minimum, the absolute minimum. So that's why it's another critical part. And obviously having the opportunity to reduce the outdoor air that's less cooling for the life of the building, less heating, less treating that air, unconditioned air. We also, section 408 touch base on the commissioning and measuring that airflow. So we obviously need it. It's a good required by code, and it's good for the facilities. Let's look at an example of an air handling unit. Let's say we've got about 25,000 CFM, we've got about 20,000 CFM return, 5,000 CFM outside air. A lot of times, engineer might opt to using tracking on the fan, or might opt to measure the outdoor air by measuring the return because it's easy to get to. Maybe it's easy to accessible. But with this example, if you look at, let's say you've got an outside air economizer, and then you're looking at the supply air tracking at the fan, you can see how much variance you get even with 5% plus or minus tolerance on it. And so if you have a larger air handling units with larger outside air, and you have a different percentage of the outside air requirement, you can see how you become difficult to validate that number. And so our recommendation is to include airflow measuring station right at the source, right at the outside air. You're going to make sure when you're looking at that to ensure that whatever pressurization you have in the return air is not affecting the amount of outdoor air coming in. Also, you gotta look at the wind speed to make sure that you're still getting the outdoor air. So having the right application, having the right type of airflow monitoring station, and having the system to it, it's very critical to make sure that you're getting the accurate reading in the application. And so for this example, we'll have two airflow measuring, one for the outside air, one for the airside economizer. And you can see kind of roughly kind of what velocities you're looking at. So knowing your velocity is an absolute in airflow measuring. So a lot of times you want to make sure you got the minimum and maximum velocity determined, and then from that determine what type of airflow monitoring station to use. If you look at the maximum size of the airflow monitoring, that's basically based on the minimum airflow. And so you can look at the velocities and you can look at the square footage. Obviously, sometimes you don't have that luxury of using that big of a free area. So you might starting to increase your velocities, and you can see kind of the range of the minimum to maximum. Now, keep in mind, like Salt Lake City, I'm not sure about the wind velocities, but typically most of the US we're looking at 11 miles per hour. That's the prevailing wind speed. And when you do the conversion, that's about 1,000 feet per minute. A good rule of thumb to stay between 200 to 2,000 feet per minute on there. Obviously, you might have an application that needs less airflow, less speed. Instead of having 2,000 feet per minute, maybe you're looking at 500 or 800. So that's kind of the range of the velocity. Understanding that range from a minimum to maximum will help you determine what type of equipment to use. Ruskin really has many different applications for the airflow monitoring. We're looking here at using a probe. It's an electronic probes. It's what we call advanced thermal dispersion airflow. DTP, it goes from 0 to 5,000 feet per minute, so you have that range for it. Now, the beauty of these thermistors is that they're really small, and that prevent dirt built up on them. And also, they don't use what previous generation, we used to use like a fragile beading glass. Now we use these are more robust. They come in with a 5-year warranty and a lot smaller. Not only they prevent the dirt, but also allow you to use much less power. So for example, this one uses about 11 VA per air measuring station. Now the number of probes is going to vary depending on the size of your opening of the duct size opening. So the beauty of these systems again is use non-proprietary cables. So previous generation you had to use a certain cable at a certain length with large connectors, so you can kind of feed them in through conduits. This one here, you can use any wire at a certain gauge. We can go up to 500 feet with that wire. So a lot longer cables, and you can use a primary, secondary without having to use transmitters. These come in an NEMA 4, and you can use up to 128 sensing points. Compare that to previous generations, to competition, we have the ability to use many number of sensing ports. Basically, the higher the number, the more measuring you have, sensing points, the more accuracy you're going to get. So again, this TTP is an excellent product that we have that can be used in ducts and plenums. Or you can opt to use everything as coming from a factory. You know, Ruskin is authority in air control, and we're the only manufacturer that can offer you a damper with an airflow measuring station, with an actuator, all built at the same factory, all commissioned and factory tested and factory wired. And all you got to do is just install it, and then you can go into a web-based. If you're using the Ruskin actuator, you have the ability to just log in, and then it's an open protocol, and you can go through there. So that's an excellent product. We call it the Airflow IQ. This comes in with many different options. You can get it as a galvanized, or you can get it as aluminum. You can put a sleeve on it that range anywhere from 15-inch to 21-inch deep. So the most we have is 21 inches. And so compare that to other layout systems where you're going to have an airflow monitoring, and then you're going to have a straight duct, and then you're going to have a damper. This is all combined into one product. Again, available with many different options on there. We also have a louver, and this louver has an integral transducer on it. And so again, it's the only one out in the industry that it's an airflow measuring louver. And so you size it based on the requirements that you need. The velocity ranges anywhere from 345 to about 2,100 feet per minute. It's 4-inch deep or 7-inch deep. And then you put a damper on it, and you put a sleeve that could be about 12 inches to 15 inches deep. It's a Class 1A rated damper. The beauty of this system is all AMCA certified. And so you've got a Class A wind-driven rain louver, and you got a Class 1A rated damper. Again, everything is factory mounted and commissioned and calibrated. One thing is we have the Ruskin leads. And so you can go to Ruskin website, type in leads, and it allows you to go into there, and then you can select an air measuring louver. You can put in the size that you need, or you can put in the airflow, the maximum pressure drop you're looking for, and then it can calculate and size the louver, and you can use that to create your schedule. It's a very handy tool to use for the air measuring or other louvers. We have another product to use. It's what's called the DART. And so if you're having a VAV application and you want to measure the airflow, and you're not really just doing an outdoor air, you're also doing maybe a zone or a system, you want to make sure that you're getting the airflow required into the space, you could use this DART. It's displaying airflow reading and temperature. It's an excellent application, say for like VAV boxes replacement, or if you're doing a VAV box with less airflow, it can read lower than 300 feet per minute. And this is available up to 16-inch in diameter. We can take a round duct and basically put a control damper on it. What we call it is a CD RAM. And so this comes in from the factory with a damper, with an actuator, and you can put an air measuring station transducer on it. And then basically you've got an airflow IQ. It's round versus square. So keep that in mind. If you have an application for a round duct, you don't have to use the airflow rectangular. You can go to the airflow round using the CD RAM and adding the AMS transducer to it. We also have air measurement that tracks your basically fans. And I've had that, but I didn't have a slide on it. But with that, I forgot to mention on the airflow IQ, we just did that for the Salt Lake prison. I think there was like up to 40 units on that job, and Destry can speak to that more, but this one was installed, and it was very quick, and basically everything was factory calibrated. So kind of went very fast here, but I wanted to be respectful of your time for 15 minutes. So any questions?
Well, I don't see any in the chat. I do have one on the airflow measurement louver. I see you guys have got that laid out with a wind-driven rain louver. Is there any plans to do that with some of the more standard products that we see in Salt Lake? Because we're not.
Yeah, we're looking into that. That's a great question. We're looking into that right now. It's only offered with the wind-driven rain for the certification to make sure we got the right velocity on it for the transducer. That's definitely, that would be an option to do that in the future.
Very interesting. Okay. Well, I don't see any questions in the chat. If anybody has anything, you've got about 30 seconds before we shut this off. Let us know. Otherwise, I want to say thanks to Ghassan, and I appreciate you doing this. We'll wrap it up for now, and we'll talk to you soon. We'll have you back on with some other products in a couple 3 weeks. I think we got the next 3 weeks booked out. So Thanks, everybody.